So let me get to the, all right. So this is lecture 13, and today is the 3rd of February, and we're going to discuss or pick up from where we left. We were talking about centroid and how to find the centroid of an area. And as I explained, there are two cases that we are dealing with. Case one is the type that we saw last time, areas defined by some functions, by algebraic functions. This is the type of problem that you will not see in the exams, or is not important. The second type, which is very important, are composite shapes. Okay, so let's get to that. What is a composite shape? A composite shape is an area defined by certain, composed of, that's what we call a composite, of different simple geometric shapes for which we do have the centroid of each shape already tabulated for us. Okay. So first, let me write down the formula how you calculate or locate the centroid of each shape. We'll talk about that later. But if you can locate the centroid of each shape, each subshape, sub area, the formula to use to find the centroid of the composite shape is this. I will first write it down, and then I will explain what that means. Okay. So let me write those down first. For X bar, okay, you need to find the summation of the product of the X centroid of each shape times the value of that sub area and divided by the total area. And similarly for Y bar. Well, I'll show you, as I said, how you can find these, but let me first refer you to a table which is in the back of your book. If you go to the back of your book, you will see there is a table where centroid of simple geometric shapes like a triangle, half a circle, parabola, and so on are tabulated. Obviously, they don't list, for instance, rectangle, you know that that is an intersection of the two diagonals. But all of these are tabulated. For instance, for a triangle, you see that 1/3 of a distance from each side. You don't have to remember these. These tables are given to you on the exam, and you just have to be able to refer to each shape. Once you divide this area into these sub areas, then the steps to follow to solve the problem are very simple. Okay. You first set up an XY system. I highly recommend you set up this XY coordinate such that the origin of the coordinate system is at the lowest left-hand corner of that shape. Then step number 2 is divide the shape into simple geometric shapes. What I mean by that, basically break it down to a triangle, a rectangle, a half a circle, and so on. Don't use, for instance, trapezoid. This is not tabulated. But remember, a trapezoid is composed of two triangles and a rectangle. So you divide this. Once you do that, you set up a table, which I will show you. Will show you. And find X bar and Y bar for this shape. What do I mean? I mean, how does this process go? So in order also to save a little bit of time, I've already set up a few examples that I want to go over and demonstrate that shows you how this procedure is carried out. Let's say you have,
Professor,
yes,
can you put the steps back up really quick, please?
I'm going to go through this example. I'll
Okay.
redo this, okay? So let's say you're given this example, okay? You always are asked to find X bar and Y bar. Step one is to set up an XY coordinate such that the center or the origin of that coordinate is at the lowest left-hand corner of the shape. This is the shape you're talking about. So I set up the X and Y axes like this, okay? Step two, divide the shape into simple areas for which you have the centroid or the centroid are tabulated. So this is what I will do for this case, okay? I can divide this into, for instance, like this. Let's consider this as area 1, okay? Then I consider this rectangle as area 2. Now, what do I do with these circles? What I will do is I have, of course, a choice here. I could consider this as one area and this as one area, but intentionally, since I want to demonstrate how you can, take into account the location of a half a circle, intentionally, I divide this way. I call this half circle area 3, and then break down this to two areas. One, okay, is this one, okay, which I call that this part, which is this half circle on top. I call that A4, and then this half circle on bottom, which I call that A5. Okay, so that's the step 2. Now, step 3 is the heart of this. You set up this table. Unfortunately, for some reason, your book is one of the few statics books that doesn't show you this tabulation, which makes your life a whole lot easier, helps you prevent any mistakes, where you are in the process, and so on. So what is this table? The first column, you just simply list these areas. You have A1, you have A2, okay? You have A3. When it comes to those areas that are virtual, that means pieces that have been cut out, we consider those areas as negative and keep track of the signs and calculations. It's a good habit to put a bracket next to those areas. So, all those values corresponding to these areas should be considered as negative values. Okay. Now, the second column of this table you just simply tabulate the value of each of these sub areas in whatever dimensions given. Here is millimeter square. So if I look at here, area 1 is 60 by 120 divided by 2. That would be 3,600 millimeters squared. Area 2 is this. Area 2 is this rectangle. Let me actually erase this so you can see the whole thing better. Okay, that's better. So area 2 is this rectangle, okay, which is 80 by 80. So that would be 9,600. Okay. Oh, I'm sorry. That is 80 by 120. That's 9,600. 80 by 120. Area 3 is this half circle. Is pi r is 60. So it would be pi r squared over 2. Okay. And that will, if you calculate that, that is pi times 60 squared over 2. You calculate that, you see that comes out to be 5,652. Area 4 is this negative piece, is also pi r squared. R is 40 squared divided by 2. You calculate that, you see that comes out to be 2,512. This is negative. So make sure you put a negative sign. Even to make it more distinct, put these brackets on the two sides so you can see it better. Same thing with A5, is the same value, 2,512. Okay. So once you set up this column, you see that you have calculated the area of each individual piece. So if you add these up, that would be sigma AI. Remember the formula for X bar, which is sigma AI XI divided by this denominator. This is what you have calculated here. So you just add those up, so you have that value. If you add them up, you get 13,828 millimeter squared. Okay, so that's that. The next column, you just tabulate the value of XI's. What are XI bars? Distance from the centroid of each shape, sub-area, to y-axis. So for A1 is 1/3 of a distance from here, 1/3 of a distance from here. So for A1, its centroid is right here. This distance is 1/3, which is 40. And also from here is also 20. 1/3 of a distance from here. Okay.
How
So
do you
this
do
is,
that?
I'm sorry, this is from the table. You look at the table, you see for a triangle is 1/3 of a distance from here, 1/3 of a distance from here. So this is 1/3, 1/3. So this 1/3 is 120 divided by 3. This 1/3 is 60 divided by 3. So this is 20 and this is 40. That's what the centroid of this triangle is. So this is what we call X1 bar. Distance from the y-axis to the centroid of area 1. So you just put it here, 40. How about the second one? This is a rectangle. The centroid of the rectangle is at the intersection of the two diagonals. So it would be halfway here would be 60. Okay. And 60. Okay. So it's 60 from here. And from here is 40. So it would be here. Okay. So this is X2 bar. which is what? Which is 60. So you just put that there, 60. A3, A4, and A5 happen to be that their centroid is along the same line. For all of them, that is for this one, X3 bar, X4 bar, and X5 bar, they're all the same as this, X2. So you just put them in, 60, 60, 60. Once you set this up, the next column is very simple. You just multiply each of these by their corresponding areas and tabulate them. Look at this formula. That's what it means. Product of each area and the centroidal distance corresponding to that. So if you find those, add them up, divide by this, you find X bar, and that's what we are doing. So you just multiply these two, very easy. 144,000, you have 576,000, 339, 120, 157.96. But remember, everything corresponding to this area is negative. So put that bracket, that means a negative value. Same thing with this one, 150,796. So if you add these up, what you're doing, you are doing this. Okay? So I add them up. If I add them up, you see that I get 757,528. If I now divide this by that, what am I doing? I am writing this equation, AI xi divided by sum of AI. That's what I'm doing. So that will give you X bar, which comes out to be 55.52 millimeter. So you found the X distance for the centroid. So you know that then the centroid of this shape must be located along this line. Okay? And this line is this X bar, which is 55.52. How about Y bar? Y bar resides along this line at a distance from x-axis that we need to find. How do I find that? Using this equation. The equation would be now sum of AI Y bar I divided by summation of AIs. This you've already done, so you don't repeat that process. So what you do now, you set up another column, which means you find now the distance from the centroid of each shape to x-axis. This is, for instance, Y1 bar, which is how much? 20 minus 60. So that would be 40. Okay. How about for this rectangle? This is 80. So this is 40, right? And this is 60. So it would be 100. Distance from the centroid of this rectangle to x-axis would be 40 plus 60, which is 100. How about for A3? A3 requires a little bit of work. This is A3, okay? Radius of 60. You go to that table, you see that the distance from the base of this half circle to its centroid is tabulated as 4r over 3 pi. That is, you need to write 4 times 60 divided by 3 pi. That gives you the value, which is the distance from here to the centroid of this A3, that is this distance, okay, that I need. This is what I need to add to this to get me the Y3. But how much is this? If you calculate this, you will see that comes out to be 15.5. Okay. Distance from here to here is 140. Oh, I'm sorry, it comes out to be 25.5. 25.5. Distance from here to here is 140. You add to that, that gives you Y3. So that would be 165.5. You do the same for these two. This is A4, right? So this is that little guy, A4. Radius is 40. So distance from here to the centroid of this little guy here, this distance is going to be this, which is 4 times r of 40 divided by 3 pi. If you calculate this, you will see that it comes out to be 17 almost. Okay? So that means you need to add this 17 to this 140, and that would be y4. So, and that would give you 157, 140 plus 17. How about for this guy? It's the same shape, so the centroid is 17 below this. So you need to subtract that 17 from this 140, and that will give you 123. Any questions? See,
Purpose of splitting that circle into two half circles?
I intentionally did that. I didn't have to do it because I wanted to show you and repeat this sort of the formula that for a half a circle is 4r over 3 pi. You could have considered that as just one whole area. So
And
the
just
centroid would be in the center of that. But I did that so to have 3 different times you need to show this formula. So
okay.
you really get to see it. Okay. Now that you have that, last operation is very easy. Now, similar to this, you just multiply these values by the corresponding areas. So 40 times 3,600, 144,000. 100 times 9,600.
Are the Y bars for A4 and A5 also negative, or is that
Oh, Y bars are not negative. The product is negative,
okay?
what we do. Okay, because otherwise, if I say this is negative, this negative becomes positive. This product is always negative. So in other words, the area is negative. That's what results in the negative value. You see, you only have areas as negative values. That's why I ended up with these negative values here. So this times that, that will give you 935,880. You multiply this positive value by this negative area, you get negative 394,584, and that is negative this 123 by that minus negative 309, 132. You add these up, that will give you AI YI bar. That if you add them up, you get 1,336,163. So if you divide this by this, that gives you Y bar, which is this AI YI bar divided by sigma AI. And you see that comes out to be 96.6 millimeters. That means the centroid is located at 96.6 from here. This is 60. This is 40. Okay, so it's somewhere here. So this is where this is y bar, and this is x bar that we found. Any questions? So really, to get to really good at it, I'm gonna do more problems. That's the only way. See, very easy. As you can see, it's a very, very simple operation. All you have to do, be able to set up that table and be careful when you're setting it up, okay? So I'm gonna do another example that I've set it up here. We want to find the x and y coordinates of this shape now, all right? So what I would do, I set up an xy coordinate, the center being at the lowest left hand corner of this shape, okay? And this is how I divide this up. I cut this again into these areas. I consider this as area 1, positive. This big rectangle, I consider that as area 2. And this little guy, I consider that as A3. So step 1, XY, you set it up. Step 2, areas, you set that up. Now step 3 is the table. Okay, so let's set up this table. Areas, I have, in this case, I have only 3 of them. A1, A2, and A3. Make sure put the bracket on the 2 sides of this because that is a negative area and you want to keep track of that. So the first column, you write the value of these areas in terms of the units given. This is a rectangle, triangle, 6 by 6, so it would be 18 meter squared. The A2, which is this rectangle, 16 by 10, 160. This half a circle, the radius is given as 2, so it would be pi r squared divided by 2, that is 2 pi. So negative 2 times pi, which becomes almost 2 times 3.14. I would say it's almost 6.3, and that is negative. Okay. Next column is xi's. How do you find them? Look at each area. For this area, the centroid is at 1/3 of a distance from here, 1/3 of a distance from here. So it is located at 2 meters here and 2 meters here. So the x bar, which is the distance from this axis to here, which is this is the x1, would be 10 plus 2. So that is 12. Okay. How about for this guy? Rectangle is right in the middle of this side. That is this distance, which is x2 bar, and that is 5, half of this. For this half a circle, center is also located along this line. So the centroid of this, which is along this line, is also at the same distance. So this is also x3 bar, which is also 5. Now, easy. Find xi, ai. That is, find the product of this one and tabulate them. 216, 800. This is going to be negative 31.4 because the area was negative. So now, if you add these up, that'll give you sigma ai, which if you add them up, you see 171.7. If you add these up, is sigma AI xi bar, which will give you the value of 984.6. So if you divide this value by that value, right, you get X bar, which is going to be 5.73. Okay, so you know now this is 5. The centroid will be along this line, which is, this is X bar, that is 5.73. How do I find this distance? Because that's where I want to find the centroid, right? You set up yi's, okay? Yi's for this one is right here. So the distance from here to x-axis, right, is 2 plus 10 would be 12. For this rectangle is in the middle of it. So this is 16, so it would be at 8. So would be right here. This is y2 bar, which is 8. Write it down. For this little guy, again, remember this half a circle. This distance is 4r divided by 3 pi. This radius is given here. Radius is 2. R is 2. So it would be 4 times 2 divided by 3 pi. If you calculate that, you will see it comes out to be 0.85. Okay, so this is 0.85. It was located at 5 from center, from 5 from here. 5 plus this 0.85, that's 5.85. Any questions? Last operation, set up yi, ai. Simply multiply these values by the corresponding areas, okay? So tabulate them here. 216, 1,280, and this one would be negative because this is positive times the negative area. That'll give you negative 36.7. Now, if you add these up, that would be sigma AI, yi, and I've added them up for you. That will be 1,459.3. Now, if you divide this by this, you get y bar, which would be 8.5 meter. That means centroid is located at 0.5 above the center of this rectangle. So this would be something like this. Okay. This is y bar, which is not, yeah. Okay. And I'm sorry, this would be, this was 8. So it would be somewhere here. Okay. 0.5 above this line. And this was X bar. Any questions? Easy, right? Well, fortunately in your class, we ended up with having more time. So I'm gonna do yet another problem. So you get really good at this. All right? So let's do that. Okay. I have a shape like this, and I want to find its centroid again. So you want to find X bar and Y bar. Step 1, set up an XY axis such that the origin as the lowest bottom left corner of the shape. 2, okay, divide 2 areas. This is how I'm going to divide this shape. I will consider okay? This square as area 1. I will consider this little circle, R is given, radius of that circle is given. I didn't put it there. So what is the radius of that circle? Let me see. Radius is, okay. I have to guess that because I haven't tabulated that here is, okay, this is 7 and this is 9.5. Okay. So the radius is 1 meter. No, I have actually tabulated that here. What am I doing? So let's call this A2. Okay. Now I will divide this way. Let me call this rectangle A3. Okay. I call this triangle A4 and this rectangle as A5. And then I have again this little half circle. I called it A6. This is negative and this is negative. Remember, okay? Procedure is same. Set up the table, the famous table. Be careful when you set this table. The only warning I have for you, do not make a mistake with signs. So tabulate the areas, A1, A2, A3, A4, A5, A6. Label those that are negative, which is in this case, your A2 and A6. Now write down the areas. What are the areas? A1 is 5 by 5, so 25 meter squared. A2 is this little circle, pi r squared. R is 1, so it would be just 3.14, and that is negative. Area 3 is this rectangle, 7 by 5. Okay, so 35. Area 4 is this little triangle, 3 by 3 divided by 2, so 4.5. Okay, area 5 is this rectangle, 4 by 7, so that's 28. And area 6 is this half circle, radius of 1, so pi r squared, which is 1 divided by 2, that means half a pi, so it'll be negative 1.57. As simple as that. If you add these up, that would give you sum of AIs. And that comes out to be 87.8 meter squared. Bear that in mind. Set up the next column. A1, its center is right here. That is the intersection of the two diagonals. This is a square. So this is its AX1, which is 7 plus 2.5. That is 9 point, XY, 9.5. How about for A2 would be the same. So this is, because that's where the centroid of both shapes are. How about for A3? This is A3. This is 7. So it would be 3.5 from here. And this is 5. So this is 3.5, and this is 2.5. Remember, so this is x2, which is 3.5. How about a4? 1/3 from here, 1/3 from here. This is 3, so this is 1 meter here and 1 meter here. So the centroid of this from this axis is 1 plus 4. This is x4 would be 5. So that would be 5. How about this guy? Is right here, halfway from here. That is where, in fact, we have put this, circle. Okay. So this is 3.5. This is 2. So this is 2. Okay. And this half circle happened to be along the same line. So that is also 2. So now if you set up XIAI, just that, as simple as that. Find the product of these two and add them up. So that'll be 237.5, 29.8. This is positive, this is negative. So this would be negative. 122.5, 22.5, 56, and 3.14 negative. Add these up, that will give you sum of AIXI bar, and I have calculated that. That is 405.6. Now, if you divide these two, that will give you X bar, and X bar comes out to be 4.62. Okay? That means the centroid of this shape happened to be, this is 4, this is 3, somewhere here along this line. That is, this is X bar, that is 4.62. How do I find the location? Going from here, you need to set up YI bars. So go again that way, okay? For these two happen to be the same, 2.5, 2.5 for these two shapes, because this is their centroid. For A3 is 2.5. Also, this distance is 5, so also happens to be 2.5. Okay. A4 is 1 plus 5 would be 6. For A5, this is 3.5. This is 5, so it would be 8.5. For this guy, again, this little guy, you have to find this distance. If you find that distance, you will see that it will be, okay, that distance is simply 0.42. That is 4r over 3 pi, where r is 1, comes out to be 4.2. This distance is 5. This is located, the base of this is along this line, which is 3. So it would be 8 plus 8.42, 8.42. Multiply this again. That's the easy part now. These corresponding values, 62.5, 7.85, which is negative, 87.5, 27, 238, and negative 13.2. Add these up, will give you AIYI bar, and total of that would be 394. divide this by that value, you get y bar of 4.5 meter. That means y bar is located right here. This is y bar of this shape. So this shape, its centroid, is located here, which is 4.62 from here and 4.5 from here. Okay? Easy topic, right?
Hey, Professor, I had a quick question.
Please.
Is it necessary at every problem we have to go back to the model and draw where y bar and x bar would be?
You need to locate them, yes. You need to locate them, yes. So for each problem, you literally have to set up these tables and find those values, if that's what your question is, right?
No, I was asking if we had to draw the centroid back on the diagram after we're
Oh,
done.
no. All you need is just tabulate this and find it. No, you don't have to. Any
Will this
question?
be on the? Will this be on the exam on Monday?
Oh, no. On Monday exam would only include, and I'll send you a sample like I did last time, would only include equivalent systems and rigid body equilibrium, finding the support reaction forces for a 2D and a 3D. I'll send you a sample like I did last time.
Okay, thank you.
Any other questions?